So let's graph our first sinusoidal function. Here we have y is equal to 2 times the sine of 2 times x minus pi over 4. Let's write down the general form of the sinusoidal function above it so we can locate a, b, and c. In our case, y is equal to a times the sine of b times x minus c. Therefore, a we find has a value of 2, b also has a value of 2, and c has a value of positive pi over 4. Remember that because I have x minus c in the general form, if I see an x minus pi over 4, the value for c must be positive pi over 4. We can now use a, b, and c to find the amplitude, period, and horizontal shift. The amplitude of a sinusoidal function is always the absolute value of a. So for us, this is the absolute value of 2, or just 2. The period is always given by 2 pi divided by the frequency, or 2 pi over b. So for us, we find a period of 2 pi over 2, or just pi. That means it'll take us a distance along the x-axis of pi, say from 0 to pi or from pi to 2 pi, to get through one cycle of this function. The horizontal shift is just equal to c, so in our case this will be to the right, or positive pi over 4. And we know that the interesting things in the sine and cosine functions happen at the quarters. So the way I'm going to label my tick marks is that I would like to label the distance from 0 to the end of the period, say from 0 to pi, divided into quarters. So my tick marks will be the period, in our case pi, divided by 4, or alternately, you can write this as multiplication by 1/4. So my tick marks will be at every pi over 4. So I'll label this on the x-axis. So from 0 to pi over 2, well, that takes us, if we go half of that distance, we get to pi over 4. So we move from 0 to pi over 4, that's going to be 1/4 of the way through the function, to 2 pi over 4, which simplifies to pi over 2, then to 3 pi over 4, and finally to 4 pi over 4, which simplifies just to pi. I might want to keep going, give myself a few additional tick marks on either side. So my next tick mark will be at 5 pi over 4, and then at 6 pi over 4, which simplifies to 3 pi over 2. To the left of 0 along the x-axis, we hit negative pi over 4, negative pi over 2, negative 3 pi over 4, and negative 4 pi over 4, or just negative pi. On the y-axis, my amplitude has a value of 2, so my maximum points will be at positive 2 and my minimums at negative 2. And I can label these with whatever I'd like. So I'll label 2 points here as 1 and 2 and negative 1 and negative 2. Now that we have our axes set up, we're ready to graph our function. Let's remember what the sine function looks like. Sine function will start at 0, then move to its maximum. Halfway through the function, we'll cross 0 again, move through the minimum point 3/4 of the way through the function, and then we end back where we started. Which means that the unshifted function will start at the origin. 1/4 of the way through the function, or at pi over 4, we'll hit our maximum point, which, given our amplitude of 2, means we hit y is equal to positive 2. Halfway through the function, we cross the x-axis again. 3/4 of the way through the function, or at 3 pi over 4 in our case, we hit our minimum value, which is negative 2, and then we end up where we started, back at 0. So this is the unshifted function. I'm going to connect these dots, or I'm going to draw a cosine wave in here using a dotted line because we're not done yet. Now we'll look at the shift. We have a shift of pi over 4, which means we're going to pick up each point and move it to the right a distance of pi over 4. It's pretty convenient for this graph since our tick marks are labeled every pi over 4. So all we need to do is pick up each point and move it to the right by 1 tick mark. Now that we have our shifted function, I'm going to connect these points using a solid line, since this is going to be the final picture of our function. Our graph doesn't start at 0, so maybe I'll add in some extra points. So starting at pi over 4, if I move 1/4 to the left, I know I'll hit my minimum. Another quarter takes me through 0. And now I've at least drawn my graph back as far as the y-axis. So there's our first sinusoidal function. Let's try another one. This time, we have a cosine function. We're again going to find the amplitude, period, and phase shift, and then graph this function. What's the general form? That's y is equal to a times the cosine of b times x minus c. So here the value for a is -4, the value for b is 3, and the value for c is negative pi over 6. The amplitude of the function is always the absolute value of a. In our case, that's the absolute value of -4, which is just 4. The period of the function is always given by 2 pi over the frequency, or 2 pi over b. So in our case, the period will be 2 pi over 3. That is, it'll take from 0 to 2 pi over 3, or an absolute distance of 2 pi over 3, to get through one cycle of the function. The horizontal shift here is equal to c. In other words, it's a horizontal shift to the left of pi over 6. We know that the interesting things happen 1/4, 2/4, 3/4, and all of the way through the period. In other words, I'm interested in knowing where my tick marks are. And since the tick marks are going to be the period split up into quarters, I'm going to take the period, 2 pi over 3, and divide it by 4, which is the same as multiplying by 1 over 4. That gives us, canceling the 2 and the 4, gives us pi over 6. So in this case, the given values on the tick marks aren't particularly useful, so I'm going to replace them. For our function, given a period of 2 pi over 3, one cycle will take us from 0 to 2 pi over 3. The steps, if I break that 2 pi over 3 into quarters, are a distance of pi over 6 apart. In other words, if we start counting at 0, our first tick mark is at 1 pi over 6. I'll write those down here as well. Our second tick mark would be 2 times pi over 6, which simplifies to pi over 3. If we take 3 steps, moving by pi over 6 each time, we're now at 3 pi over 6, which simplifies to pi over 2. And 4 quarters later, we're at 4 pi over 6, which does in fact simplify to 2 pi over 3. So we can keep going and give ourselves a few extra steps to the left and the right. On the left side, we'd have negative pi over 6, negative pi over 3, negative pi over 2, and negative 2 pi over 3. And that should be enough for this graph. The only thing we haven't labeled yet is our y-axis. Since our amplitude is 4, I'll give 2 tick marks here and label these as 2 and 4, and -2 and -4. Again, the scale you choose here is up to you. So now that we've prepared our axes, we're ready to graph this function. Let's have another look at the formula. So we're looking at a function that is a cosine wave, and cosine normally starts at its maximum, then 1/4 of the way through the function crosses 0, crosses the x-axis, then hits its minimum, well, halfway through the function, 3/4 of the way through the function, sine hits 0 again, and all the way through the function, we're back where we started at the maximum. But this function is a reflection along the midline, along the x-axis in our case. It doesn't start at its maximum because a has a negative value. This function, this cosine function, will start at the minimum value. So we'll start at y is equal to -4. So once again, 1/4 of the way through the function will cross 0, but now halfway through the function, instead of reaching our minimum, since this is a reflection, we'll reach our maximum. 3/4 of the way through the function will still cross the x-axis, and all of the way, or 4/4 of the way through the function, will hit the same place, same point that we started along the y-axis. So we'll hit the minimum. Let's tidy this up a little bit. These points are the ones we're not going to use. So this is the unshifted function. So I'll connect the points with a dotted line to remind myself that I'm not quite done yet. What is this shift? Well, our given shift is -π/6. And -π/6 is pretty easy to locate on this graph since our tick marks are π/6 apart. So I'm going to pick up every single point and move it to the left by 1 tick mark. So that means that at -π/6, we're at the minimum point. At 0, x is equal to 0, we cross the x-axis. At x is equal to π/6, we're at our maximum. At x is equal to π/3, we're again at 0. And at x is equal to π/2, we once again reach the end or the beginning of our next cycle, and we're at our minimum point. Now we connect these dots, making them look like our expected cosine wave, and that is a picture of our final function. It's one period of the function. Okay, keep this going both towards the right and towards the left using the same strategy. But as long as you've graphed at least one period, then we're done.